All right, Luanda, in this demonstration, what we're going to look at is the phases of the moon. Now, we've got our light bulb here to represent the sun again, and we have our Earth here represented by the globe, and now Luanda's holding the moon. All right, so we've got a softball that's going to represent the moon. And actually, that's about the right size compared to the Earth for the moon. Okay, it's pretty close, maybe a little bit small. But what we're going to do is we're going to look at how, as the Earth revolves around the sun, the moon revolves around the Earth at the same time and causes the changes we see in the phases of the moon.
Before we move on, we want to clarify a revolution and a rotation.
Okay.
A revolution is when one celestial body makes a complete circle around another celestial body, whereas a rotation is when a celestial body is spinning on its axis.
Exactly, okay. So, yep, revolution would be orbit, rotation would be spin.
Correct.
All right, we're going to start with what we call a new moon.
Okay.
Now, during a new moon, we don't see the moon, all right? During a new moon, half the moon is always illuminated by the sun, but the half that's illuminated is actually facing away from us. Okay. And so, at this point, for an observer here, where it would be nighttime, notice the moon would be on the other side of the Earth, and for the people that would be up here during the daytime, we wouldn't see the moon in the sky most likely because the sun is so much brighter. You know, the stars are out during the day. We don't see them because the sun's so much brighter, it kind of bleeds them out. Occasionally we'll see that we do see the moon during the day, but not when it's in the new moon phase.
Okay.
And notice the other thing is the orientation we have at this point. We have the sun, then the moon, and then the Earth. So for a new moon. Okay?
Let's move around.
Exactly. Now the moon goes around the Earth counterclockwise from viewed above the North Pole. So at this stage, we'd have what we would refer to as the first quarter. All right. In between here, we would have seen a crescent moon that would have been getting progressively brighter on the right side of the moon. Okay, the little way I remember that is a waxing moon is the moon light on the right, the moon's getting bright. Still half the moon is illuminated, but we're only going to see a quarter of that moon.
So, Joe, this entire half of the moon is illuminated. Mm-hmm. The issue is, this is the Earth. From the Earth, you will not be able to see this half.
Exactly.
So you're only going to be privy to a quarter.
All right, and that's what we refer to as first quarter. Exactly. Now I'll have you go a few more days beyond, and now at the orientation we are here, where we have the sun, the Earth, and the moon, this would be what we'd have for a full moon. Now for these observers over here, which would be nighttime, they're faced away from the sun or rotate away from the sun, they would see the whole illuminated half of the moon, and so we refer to this as full moon. It's kind of funny we refer to this as full moon when we only see half of it, or we did refer to that as the first quarter, we'll get to the second quarter, but we refer to this as full moon. And the other interesting thing is we always see the same side of the moon, because at the same speed that it revolves, it also rotates at the same speed, so the same side of the moon is always facing the Earth. Okay?
So we never see the dark side of the moon.
We didn't see it until I told the kids, we never saw that until the 60s when we finally got a spaceship that could fly around the other side to take some pictures to send back.
Good.
Okay, so now let's move to our next stage. Now this would be considered a waning moon. All right, from where we were here to new moon to full moon, the moon was getting progressively brighter and brighter. Okay, now it's going to be getting dimmer. We're going to see less and less of the illuminated half of the moon. So this stage here now would be the last quarter. Notice now that this is the side, the illuminated side that an observer would see, and so now it's on the left. Okay. So a waning moon, one that's getting smaller, is illuminated on its left side, all right? And this would be referred to as the third quarter. Now we went through the gibbous stage earlier. Go ahead.
Right. And once again, an entire half of the moon is illuminated, but because of our standpoint from the Earth, we're only seeing 1/4 of the Earth.
Exactly.
Of the moon.
Of the moon. And these are stages where, occasionally we do see it for part of the daylight when it's still is bright enough in the sky.
Yes.
Sometimes we can see it during the day.
Right, I've seen it.
All right. And now we'll continue on to what would be new moon again. Now that whole phase from new moon to new moon took about 29 and a half days. But the unusual thing about that is the moon actually makes one complete revolution in 27 1/3 days. Now what's the difference in that? Well, remember now that the same time the moon is going around the Earth is moving. So if the Earth stood still and you moved the moon around one complete revolution of the moon, it would get back to new moon where we had the sun, the moon, the Earth all lined up together, and 27 1/3 days. But because at the same time that the moon is going around the Earth is moving in its orbit. And now that we get back to this point where you were right here, it's going to, right here would be 27 1/3 days.
Right.
But until we get over here again, all the way back to where we started, it's going to take a little bit over another day, and that's why there's that difference in the length of the two cycles.
Okay.
So the moon revolves in 27 1/3 days, but the phases are about 29 1/2 days.
Right. Before we move on, I would like to just clarify 2 points. The position of the celestial bodies during a new moon. You will always have the sun, the moon, the earth. During a full moon, you will have the sun, the earth, the moon, in that order.
Exactly.
Thank you.
Okay.